Hello ma'am, what is single water pass condenser? Which formulas are used to solve the problems on single water pass condenser and how to apply these formulas by using Mollier diagram as well as steam table? Let us first understand what is single water pass condenser with the help of diagram. So when water is flowing in one direction only in the condenser, then it is known as single water pass condenser. There is no any use of baffles in this type of condenser. Now we will understand the whole process. Here in the boiler, water is getting evaporated and it is passing to the turbine. So this water evaporated is at high temperature as well as high pressure. Now in turbine there is the expansion process and here water and vapor mixture is coming out from the turbine, is entering into this condenser. And here single pass water condenser is used. That means in these tubes water is flowing in one direction only and here water plus vapor mixture is getting condensed into the saturated water, and here is the condensate out, and from this pump this condensate is again supplied to the boiler. So this cycle is getting completed by using single water pass condenser. Now how to apply the formulas regarding such a type of given problems? Then we will solve one problems. I will read what is the given question. A surface steam condenser is to be designed for 120 megawatt thermal plant when the steam is supplied at 150 bar and 600 degrees Celsius. The condenser pressure is 0.08 bar. The water side and steam side heat transfer coefficients are 1000 watt per meter square degree Celsius, 5000 watt per meter square degree Celsius respectively. The inlet and outlet temperatures of water are 25 degrees Celsius and 35 degrees Celsius. The condensate is saturated water. Determine the number of tubes required if inner diameter 2.5 cm and outer diameter 2.9 cm and length of the tube is limited to 5 meter. Arrangement of the condenser is single pass shell type. Assume there are no losses and expansion in the turbine is isentropic. So this was the given question. Let us first understand the given data with the help of diagram. Now plant capacity is given 120 megawatt. So we will write here that is the capacity is 120 megawatt. Then initial condition of steam. So here initial condition of steam, that means steam is entering into the turbine. So here is the initial condition. So we will take here as a suffix 1. That is at this point 1 initial condition of steam is given 150 bar and temperature is 600 degrees Celsius. Then when it is entering into this turbine, there is the isentropic expansion is taking place. So due to this isentropic expansion, entropy remains constant and this pressure as well as temperature of the steam is getting decreased. So after coming out of the turbine, we will consider here the point 2. Then water side heat transfer coefficient is given. So this is the single water pass condenser. If we observe, water is flowing inside the tube and steam is flowing outside or over the tube. So when it is given that water side heat transfer coefficient. So here heat transfer coefficient of inside the tube. So we will say that HI. So this heat transfer coefficient HI is equal to 1000 watt per meter square degree Celsius. And steam side heat transfer coefficient. So steam is flowing, that is here steam is flowing over the tube. So this is the outside heat transfer coefficient. So we will say HO. So HO is 5000 watt per meter square degree Celsius. Then Inlet water temperature and outlet water temperature is also given. TWI 25 degrees Celsius and TWO 35 degrees Celsius. So I will write here is 25 degrees Celsius and here we will say 35 degrees Celsius. Now the condensate coming out is in the form of saturated water, and this is also mentioned in the question. Now if we have to find out the enthalpies at different points, then how to find out? So at point 1, as per these conditions, we have to find out the enthalpy at point 1, that is H1. And the expansion process is isentropic process, so we have to show entropy constant, and at point 2 we have to find out the enthalpy H2. Then here condensate is coming out in the form of saturated water. So enthalpy of this saturated water we have to show that as a HF2. So here the enthalpy is nothing but HF2 at this point. Then inner diameter of tube is given. So these are the tubes and inner diameter is given 2.5 cm, outer diameter is 2.9 cm is given. Length of the tube is 5 meter, and what is the question? That we have to find out the number of tubes. Now we will move for the calculation by using the Mollier diagram as well as steam table. Now we will understand how the condensation process is taking place. Here the condenser pressure is given, and that is equal to 0.08 bar. At this pressure, steam plus water mixture is entered in the condenser and it is getting converted into saturated water. So at the 0.08 bar pressure, the temperature of the steam remains constant inside the condenser. Only there is the phase change, and during this phase change the heat is released which is absorbed by this water. Now how to find out the temperature? So from the steam table, by using the pressure table, because the pressure is given, we will find out the temperature. So here saturated water and steam pressure table is given and we will find out the temperature. So in the first column there is the 0.08 pressure is given, and at that temperature in the second column temperature is given, that is 41.5 degrees Celsius. So we can say that the condensing temperature is 41.5 degrees Celsius. So this temperature will remain same throughout the condensation process. Only here the change in water temperature, at the inlet of water there is 25 degrees Celsius temperature and outlet it is 35 degrees Celsius temperature. Now we will use the Mollier diagram and we will find out the enthalpies at point 1, that is H1, and the enthalpy at point 2, that is H2. So while we are going to find out the enthalpy H2, we have to consider the pressure that is the same, that is the condenser pressure 0.08 bar. This is the Mollier diagram. On this horizontal line there is entropy and vertical line there is the enthalpy. Now we will find out what is the initial condition of steam and we will locate the point. So as per given data, initial condition of steam is at 150 bar pressure and 600 degrees Celsius. Now if we observe, here is the pressure in bar is given. So here is the 100 bar and here is 200 bar. So in between this, we have to select one point, that is the point will be at the middle line, and that will be equal to 150 bar, and temperature is given, that is 600 degrees Celsius. So if we observe, these green lines indicates the temperature in degree Celsius. So first we will select one particular point. So here is 600 degrees Celsius temperature, and we have to select the middle line in between this 100 degrees Celsius and 200 degrees Celsius. So here is 1, 2, and here is will be the third point. Now process of expansion is isentropic. That means entropy remains constant. So if we observe on this horizontal line, there is the entropy. So we have to show constant entropy. So we will draw straight vertical line to show the constant entropy. So I will draw here one line. Now we have to extend this line up to a pressure line of 0.08 bar. So if we observe, here is 0.05 bar pressure line and here is 0.1. So in between these two lines, we have to show the second point. So we will extend this vertical line and here is 0.1. So after this 0.05, we have to show this 0.08. So here in between the 0.05 and 0.1, we have to show this point. Now we will find out the enthalpy. So the initial condition of steam, we will locate here as a point 1. Now I will draw horizontal line with the help of the different color and we will find out the enthalpy at point 1. So here is straight horizontal line and what is the enthalpy? Now it is after 3500. So enthalpy at point 1 is 3580 kilojoule per kilogram. Now in the same way we will find out what is the enthalpy at this point 2. So at this point 2 again we will draw straight horizontal line and what is the value? So value at point 2, that is H2 is equal to 2080 kilojoule per kilogram. Now by using steam table we will find out the value of HF2, that is value at the outlet of the condenser. So here temperature is given at 0.08 bar 41.5 degrees Celsius. So at this temperature we will find out the value of HF. So temperature is given. So we have to use here temperature table, that is the saturated water and steam temperature table. Temperature is 41.5 and we have to find out the value of HF. So here the value is given and at this 41.5 we will take HF2 because here the point 2 is there, 174 kilojoule per kilogram. Now we will move for the calculation part. So it is given that the capacity of the plant 120 megawatt. So how to find out the rate of flow of steam or mass rate of flow of the steam? So when capacity of the plant is given and here the isentropic expansion is taking place, so change in enthalpy is H1 and H2. So here we will take this enthalpy difference multiplied by the mass rate of flow of steam, which is equal to plant capacity, that is 120 megawatt. So we will write here the formula MS H1 minus H2, which is equal to 120 into 10 raised to 3. So megawatt we have to convert into kilowatt. So when we put all the values, so value of H1 3580, H2 2080, which is equal to 120 into 10 raised to 3. So MS is equal to 80 kilogram per second. Now we will move for the next, that is heat lost in condenser. So how to find out the heat lost in condenser? So here MS, that is the mass rate of flow of steam, is known. So same mass rate of flow of steam is moving inside the condenser. So here heat transfer process is taking place. So we will say that Q is equal to MS and the enthalpy difference H2 minus HF2. So H2 is known, HF2 is also known, MS is also getting calculated. So when we put the value, we will get Q is equal to 80 into 1906 kilojoule per second. Now we will calculate the overall heat transfer coefficient. So here is the formula that you have to note down, because heat transfer coefficient inside the tubes as well as outside the tube is given. Inner diameter of the tube and outer diameter of the tube is also given. So here is the formula 1 upon UO, that is U to the base O, that is the overall heat transfer coefficient, which is equal to 1 upon HI. So HI is 1000 multiplied by DO by DI. So both these diameters are given in centimeter. Standard unit is meter, but here centimeter is getting cancelled. So we will write 2.9 by 2.5, which is plus 1 by HO, that is 1 by 5000. So answer this. So when we solve all this, then we will get 0.00136. But here 1 upon UO is equal to 0.00136. Therefore UO is equal to 730.3 watt per meter square degree Celsius. Now we will understand how to calculate log mean temperature difference with the help of diagram. So this log mean temperature difference is related to heat transfer process that is taking place in the condenser. So here temperature of steam that we have already find out that remains constant, that is equal to 41.5 degrees Celsius. So we have to draw here two lines. So at the inlet temperature is 41.5 and at the outlet temperature remains same, that is 41.5. So we will draw here one straight line. Then what is the temperature of water at inlet? That is 25 degrees Celsius. So we have to mark here one point, that is 25 degrees Celsius, and outlet 35 degrees Celsius. So we will mark here one point at 35 degrees Celsius. So we will join this, that is the temperature is getting increased from inlet to outlet. Now we have to take the difference in between the inlet of the temperature of steam and water, that is theta I. This difference is known as theta I. And we have to also take difference at the outlet for the temperature of steam and water, and this is known as theta O. So when we calculate this theta I and theta O, then LMTD is equal to theta I minus theta O divided by log to the base E theta I by theta O. So when we solve this, we will get 13 degrees Celsius. Now what is the formula for heat transfer? Q is equal to overall heat transfer coefficient multiplied by area multiplied by LMTD. So this Q is already getting calculated. This UO 730.3, A that is unknown, and LMTD that is 13. So area, this is known as the surface area of the tube. So this is 15.95 meters square. So how we will define this surface area of the tube? So this is the outside surface area. So we have to take total length of this tube, that is also given, pi DOL. So this is the total surface area, pi DOL multiplied by the number of tubes. So if we observe here only one unknown term, that is the number of tubes. So outside diameter is given in centimeters, so we have to convert it into meter, that is 2.9 divided by 100. So value of N is equal to 35 tubes, and this is the answer.